Okay, let's start today's session. Today I'm going to do further relative velocity part. Further relative velocity part, surely this part belongs to your exam paper. Okay, so see this one. See this one first. I'm going to consider a motion with a river. Motion with a river. You consider, here this is a river. So the velocity here you take u. Velocity take u. Then r river. Then velocity of river with respect to earth. So that is given u. That is given u. Okay. Now you consider a man who can swim in still water. Let's say this point A. A man with respect to earth in still water mean with respect to river. Okay. So man with respect to river, let's say V. Let's say V. Here this point on this bank, the point capital A. Okay. Now here man with respect to river V. This is called velocity of man with respect to river or in still water. In still water mean that is given with respect to earth. That is given with respect to earth. Okay, now he gonna move along some path like this. Like this. So here downstream and here upstream. Here upstream. Here downstream. So here V value. When you consider V value, there are three possibilities now. V greater than U, V equal U, we have V less than U. We have three different cases. So as according to those cases, the motion can be happen. As according to these cases, motion can be happen. Okay. You consider V value greater than U. V value greater than U. Then he can move upstream. No? He can move upstream. If he can move upstream, he can go along any path. If he can go upstream, then definitely he can go along any path. That is the specialty. So here in this case, he can't move upstream, but when he try to swim upstream and the velocity of the river downstream u, then both equal mean he is at rest. No? He is at rest. Then he can't move upstream. He can't go this way, but below that he can move any path. Okay. For this case he can move any path, along any path. For this case he can't go upstream. Therefore he can go downside any point. When you consider this one, he can't go upstream and as well as he can't go directly opposite point, and he can go some point in downstream. But we have to think what is that point. We have to think that what is that point. Okay, that's the cases. Those are the cases. So today we are going to discuss this part clearly because this is very important part that will be definitely for your exam. Okay, just write down this. Motion in a river. Motion in a river. Okay. Just write this way. Let a river with velocity u. Let a river with velocity u parallel to the banks. Parallel to the banks. Let a river with velocity u parallel to the banks. And a man who can swim in still water, is V. Who can swim in still water is V. First point, right? The velocity of man in still water V means, the velocity of man in still water V means, the velocity of man in still water V means the velocity of man given with respect to the river. Velocity of man with respect to the river. Next point. As according to the magnitude of V, as according to the magnitude of V, as according to the magnitude of V, path along the river can be changed. Path along the river can be changed. Path along the river can be changed. Okay. Now you better sketch this part. Just sketch. Now with that one you sketch this. With that one you sketch. Here consider U, V greater than U case. V greater than U case. Okay. Now here this case, he can go along any path, any direction. He can go along any direction. Whatever it is, okay. Okay. So we're going to check that one, how it is happen. So now next case, V equal U case. V equal U case. Now here he can't move directly opposite, but he can move downstream any point. Here velocity U, here velocity U. He can move downstream any point. He can't move directly opposite an upstream point. Okay. So here you consider V less than U case. V less than U case. So you consider this bank point A. He can't go directly opposite, but here there's shortest path. This is shortest path. Then thereafter he downstream, below that he can move any other point, any other path. Here shortest path. Shortest path. Okay. Here for this case, perpendicular one will be the shortest path. This is shortest path. But here this case we can't discuss about shortest path. No? So directly opposite he can't move. Then 1 millimeters below that possible. 1 nanometer point possible. 1 micrometer possible. Then we can't discuss actual possible shortest path. Okay. But here this case we can say this will be the shortest path. For this case we can say about shortest path, then below that he can move. For this case he can move any point downstream. Okay. You better to put that one. Now let's discuss how it is happen. So we need to discuss here this one shortest path, and we need to discuss shortest path for this case. So always you remember the minimum time we can obtain by swimming perpendicular to the bank. Here shortest path one thing, then minimum time will be another thing. Okay, with star mark write down. For each case, the minimum time to cross the river. For each case, the minimum time to cross the river is obtained by swimming perpendicular to the bank. By swimming perpendicular to the bank. By swimming perpendicular to the banks. Okay. Now let's analyze one by one. Okay. Now, minimum time case. Here consider you. Here man starting at point A. Then here velocity of river with respect to earth given u. Velocity of man in still water mean with respect to river given v. So here v can be greater than 0, v can be less than 0, whatever it is, okay. Now here I'm gonna swim perpendicular to the bank. So now he's gonna swim perpendicular to the bank. Here say v, then river velocity u. Then definitely with the resultant he will move, no? Here resultant path. Then take velocity v1, here take angle alpha. Then we can find v1 value. v1 value u square plus v square root, no? By the Pythagorean theorem you can find, no? Then alpha value tan inverse v divided by u. Okay? Here this belongs to path along the river, no? Here path along the river. Okay. Now you consider here downstream velocity u perpendicular to the bank velocity v. Then definitely crossing happen with v, no? The crossing happen with v, not with u, no? So this belongs to crossing thing. You consider here breadth simple d. Then time to cross the river. Here d, then corresponding velocity v. Here time to cross the river, d divided by v. Then, so this part, let's say b. So here displacement, downward displacement because of the velocity of river, that is b. Then b value equal, then here alpha, we know alpha, no? Then tan alpha value d divided by b. And further tan alpha value v divided by u. u is given, then we can find b value. b value du divided by b. Okay, du divided by b. So for this case, here he go along this path. So anyway, then here directly opposite point b, then below simple b displacement downstream, then below that b displacement du divided by v. Then here length of the path along the river. Let's say length of the path along the river. Here this is alpha, no? This is d. Then you can resolve this one, d over cos alpha, no? Here this length, d over cos alpha. let's say here this one, point C. D over sine alpha. Here alpha, here D over sine alpha. Then you can find sine alpha by this. Then here this is tan alpha, no? Alpha, tan alpha value V over U. Then U square plus V square root. Then you can write tan alpha value. Sorry, sine alpha value. Then D over sine alpha, V over that thing, no? U square plus V square root. Here path along the river. Length of the path along the river. Length of the path along the river. Okay, you better to put that one. Then just remember, if we need to cross with minimum time, definitely have to swim perpendicular to the bank. So if he swim perpendicular to the bank, then with the river velocity, he go downstream. But he cross with minimum time. He cross with minimum time. Very important thing. Okay, put that one. Okay, now see why this D over sine alpha. See why is that D over sine alpha? You consider here right angle triangle. Right angle triangle. Here you consider A, angle alpha. We say this one A cos alpha. A cos alpha. Here this one A sine alpha, no? A sine alpha. D cos alpha. A cos alpha. A sine alpha. That's how we usually resolve. Then you consider here, take this angle alpha, this point, this length A. Now we have to resolve to hypotenuse. This hypotenuse we resolved previously. Now here this one. Then you consider here B. Then cos alpha, A divided by B. Then subject B equal A over cos alpha. Then along this angle we say A over cos alpha. So you consider this angle beta, say this one C. So if you need to resolve this C to hypotenuse, then here this A, when you need to resolve hypotenuse, sine beta equal A divided by B. A divided by B. Then subject B equal A over sine beta. A over sine beta. So if we need to resolve hypotenuse, then we can just write A cos alpha, A sine alpha. But if we need to resolve to hypotenuse, then we have to divide that one sine alpha or cos alpha. So we have to consider both. Okay, if you have doubt, just write it. Yeah? If you have doubt, just write. Okay. Okay, now next case, just write. Next case, the previous one with minimum time, no? Now this case with shortest path. Okay, write down crossing the river with shortest path. Crossing the river with shortest path. Crossing the river with shortest path. This is very important. Crossing the river with shortest path. Okay. Now, see previous case, velocity of the river U, then take this point A, then take exactly opposite point B, then velocity of river with respect to earth u, velocity of man with respect to river given v. Okay. Now here we have to think about three cases. We have to think about three cases, that is v greater than u, v less than u, v equal u. According to that, that will change. Okay, now velocity of man with respect to earth. Velocity of man with respect to earth, write relative velocity theorem. That is addition of two velocities. Start with m, ends with e. You have to put here common r. This is called relative velocity theorem. That is again triangle law of vector addition. So here start with m, ends with e, common r you put here. Then rm, this is v, er, that is u. That is u. That is the data set. So now we know this is triangle, vector triangle, no? Vector addition here. So first you put here pq. Here take pq vector. Take pq, then this will be qr. qr vector. Then you put resultant pr. Resultant pr. Here this is pq vector, then qr vector, here pr vector. You have to take them. Now let's start. Sketch PQ. So see clearly. Here this is PQ. PQ. That's magnitude U. Then here QR, magnitude only we know magnitude, that is V. That is V. Then Q we know. Then R point, magnitude with V, no? Magnitude V. Now start here, this point. Sketch possible R points now. Sketch a circle. Now here say V greater than U case. If V greater than U, here first on V greater than U case. So such case V value somewhat greater than U, then Q center, radius V circle. This is possible R points. Here these are possible R points. So definitely you have to take Q as the center, okay? Definitely you have to take Q as the center. Then here possible R points. Possible R points. Now PR. PR mean here P, no? Then R. We can take any direction. We can go along any direction. Then I told you, so when V greater than U case, he can go along any path. Then here this path possible. This path possible. Here downstream possible. Here any other directions are possible. Any other directions are possible. Upstream seeming possible. Here upstream seeming possible. Then here possible. And likewise, here this path is possible. Here this will be the shortest path. So that belongs to this triangle. Here take this point R. Then this R possible with comes with shortest path, no? Then the radius of this circle we know, that is V, no? Radius of the circle V. Then PQ vector, QR vector, the resultant is PR. Now say this is shortest path. Shortest path. So consider here breadth D. Now we know here U, here V, then PR you can find PR value by the Pythagorean theorem, V square minus U square root. Then with this velocity we have to move, no? So you consider this angle alpha. That means he have to swim along this direction. So along this direction with this velocity of river U, then the resultant become perpendicular to the bank. Okay. Here he have to swim in the river this way. Then with the river velocity, then resultant comes with this path. Okay. Okay. Now here velocity of the river, say that is U. Then he have to move along this path. So take this angle alpha. Take this angle alpha. Its velocity V. Then here this is we call resultant path. Resultant path. Okay, now here this is displacement diagram and here velocity diagram. Here displacement diagram and velocity diagram. But there's connection, that means this alpha connected with displacement diagram. Alpha connected with displacement diagram. Okay, put that case, then shortest path is this. Then we can take time to cross the river. Time to cross the river. So we have to move this displacement d with velocity here, resultant PR value. Then d divided by v square minus u square rule. Now here the time to cross the river. That is the time to cross the river. Okay, complete. This is V. Here this is V. So here the case. Here velocity of river U. Then he swim with velocity V with angle alpha. Then the resultant path becomes this. That is the resultant path. So when we vary this V, then according to that, here this resultant path will change, no? Resultant path will change. The thing is, we can go for V greater than U case, we can go along any direction. We can go along any direction, that's the case. Now, better to put stomach and write down here. When V greater than U, just write, when V greater than U, when V greater than U, man can cross the river, by moving in any direction, okay. Okay, now you just consider second case, V equal U case. So you consider same data set. Here sketch PQ vector first, that is U. Then let's sketch PQ vector. U. Then QR vector. Here QR vector is V, no? Magnitude V. Then we know UV both are same, no? UV both are same. Then Q center, radius V circle passing through this point P and sketch a circle. Q center, radius V equal to U now. Here the circle now. Then here possible R points. Now, for this case, he can't go along this path because we can't find R point on the circle. Then here this part not possible. Then not possible to move. Directly opposite point, not possible. But here see, he can go to any other point in downstream. Here. Then he can go any other point. Okay. Then shortest path we can't discuss. Shortest path we can't discuss here. Okay. Then directly opposite one, not possible. Then shortest path can't discuss. That part can't discuss. Okay, you better to put that one. Complete. Okay. Then let's discuss further. V less than U case. V less than U case. So see. Then you have to think about same data set. Okay. Then here same data set. Here PQ vector for sketch, that is magnitude U. Then QR vector magnitude V, direction unknown. Then we have to think about PR. Then crossing the river mean motion with respect to Earth. Okay. Okay. Now further see. Now you sketch. Here vector PQ. First vector PQ, magnitude U, magnitude U. Then QR, magnitude V, no? Now V value less than U, not exceed this point. Then Q center, radius V circle. Sketch now. Here corresponding circle, Q center. Here possible R points. Possible R points. So he can't move directly opposite and he can't move upstream. But here, when you consider this tangential path, we can find R point. No? Take this angle alpha. Here this is V. Then here the resultant velocity. Resultant velocity. Now when you go to this displacement diagram, the point A is here. Then the resultant velocity, usually man move with along the direction of that velocity direction. No? Then here, that's the path. Angle alpha belongs to that. Here this is we call shortest path now. Shortest path. Then other than that, he can move below that any other point. Here he can move any other point. But here this will be the shortest path. Then for this region he can't move, no? For this region he can't move. That's how he crossed the river. Then you have to consider this one as the shortest path. Now here U known, V known, you can find PR. No? PR, here VU, Pythagorean theorem, U square minus V square root. Then alpha value, sin alpha V divided by U. V divided by U. Then you can find any other trigonometric ratios. No? Here alpha V U, here U squared minus V square root. Then by that one you can find all the other ratios. Okay. Then cos alpha, here V squared minus U square root divided by U. Likewise you can find all the others. Then here we know Here breadth is D. Here angle alpha, alpha. Then length of the shortest path, length of the shortest path here D angle alpha, no, then here this length will be D over sine alpha, D over sine alpha, no. Here alpha, here D, we have to take this length D over sine alpha, then you find sine alpha, that is V divided by U, D V divided by U. Then here length of the shortest path. Now the previous case we can move perpendicular to the bank, but this case we can't move, no, this case we can't move, then that will be the shortest path, du divided by V. Okay, complete. Then same time let's find time to cross the river, time to cross the river. Then you can take this length, that is B du divided by V. So along this path the velocity is PR, no? Then here length of this path du divided by V, then along that path velocity PR, then you divide by PR now. Then simplify, du over V PR U squared minus V square root. Now here, now the time to cross the river. Okay. Then you can take this length of the path, divide corresponding velocity. Divide corresponding velocity. Continue. Now you think about three cases. So first case, he can move along any path. Second case, he can't go upstream, he can't go directly opposite point in the other bank, but he can go any other point in below that. For this case, we have shortest path. We have shortest path. Then below that he can move, but upstream or any other point above that he can't move. But when you consider all the other cases, here see, we have two possible R points, no? We have two possible R points. Two possible R points mean we can have two possibilities for that motion. We have two possibilities. But when you consider this R, PR value somewhat less than, then when you consider this one, then PR value somewhat higher than that, no? Here small, here somewhat high. Therefore, if PR magnitudes somewhat less, then corresponding time minimum, no? Then time maximum. Then he can cross the river with two cases. He can cross the river with two cases for these. Okay? But time can be different. Time can be different. Two possible cases. But for this one, we have only one possible R point. One possible R point. That means we have only one possibility. For this case, again, we have only one possibility. But here, this case, we have two possibilities because of two R points. Better write that one there. Better write that. Below the shortest path, write somewhere either here. Below the shortest path, he can cross the river with two possibilities. 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 Okay. Let's you better to not one. You better to label, take one path. You consider one path. You better to label here R1 and R2. You better label here R1 and here R2. If you can sketch new diagram, that is okay. If you can sketch new diagram, that is okay. But anyway, you have to clearly label R1 and R2. Those are the cases. Then PR1, we take minimum time. PR1, that take minimum time. PR2 take higher time. No? With another star mark, write down PR1 and PR2 are the cases. 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 Since PR1 less than PR2, since PR1 less than PR2, then TPR1 greater than TPR2. Then take here time to cross the river with PR1. Here TPR1 greater than TPR2. Just write. Then PR1 less than PR2. Then resultant velocity is small. No? Then corresponding time will be higher. The corresponding time will be higher. No? Okay, just write. Just get that idea first. Okay, then here I told you very special thing. So that is the concept of crossing a river. Crossing a river. Okay. Let's move a little further. Let's move a little further. Okay, just write, let a river with velocity u parallel to the banks. A man who can swim in still water, a man who can swim in still water, a man who can swim in still water with velocity v, willing to go A to B, willing to go A to B. A man who can swim velocity v in still water, willing to move A to B, willing to move from A to B. Okay. Within bracket write down v greater than u. Here this condition given. V greater than u given. Okay, you start with me. Sketched river u, velocity of river with respect to earth u, velocity of man in still water mean with respect to river v, then we have to consider velocity of man with respect to Earth. Then addition of two velocities, mr, re. So mrv, here u. Here are the cases. Then previous one, label PQ, here QR vector, here PR vector. Here just these are standard. You better to practice this way first. Until you become familiar, you better to consider PQR notation. You better to consider PQR notation. You can label any other notations, but you better to select one format first. Okay, do up to that. Okay. Now, here first one. Here river, point A somewhere here, point B somewhere here. Now I need to move A to B motion. Therefore, velocity of man with respect to Earth, you need to consider here this way. Moving A to B, first case. Now you sketch PQ, here PQ. Do with me. Then V value greater than U, no? Then sketch possible R point here. Q center, V radius circle, sketch. Here is Q center, radius V circle. Then I need to go downstream. Then here possible R. Anyway, here U, radius V, then corresponding PR value, U plus V. When he swim downstream, then velocity addition will be the resultant velocity. No? So downward velocity U, then he swim with velocity V, then addition will be the resultant. Now take here simple A, AB length A, then time to move A to B, displacement A, corresponding velocity PR, no? Then A divided by U plus V. Here case 1. Okay, complete. That is A to B motion. Here man with respect to Earth. Velocity of man with respect to Earth, downward. That will be the resultant value. That is PR. Start here, end here. Then PR. Here this radius V, no? Radius V, then U plus V is the resultant. U plus V is the resultant. Okay. Now you consider second one, B to A motion. Okay. Then A to B downward, B to A upward. Then corresponding one. Then direction upstream. Then from here circle, and U won't change. Then only this vector will change. Then upstream, here it is, R. Then here radius V, magnitude V, the resultant only this part, that PR will be V minus U, no? V minus U. Now we know he can swim upstream V, but down velocity of the river U. Then opposite directions, V minus U will be the resultant. Therefore, now he move A displacement with velocity, now here B to A time, A divided by PR, that is V minus U. Okay, put that on as well. And here B to A motion. Second case, you better sketch another circle and do all at once. Okay, better do all because this part very important. Okay, complete now. Okay, now see, now AB, here point A, B, here somewhere here perpendicular to the bank, say displacement D, say A. Now here with respect to man velocity with respect to earth, he need to move perpendicular to the banks, no? Here this will be the resultant now. Now here PR, PQ, then PR perpendicular to the bank, then here this will be R, that will be resultant. Then to happen that one, he have to move with inclination alpha up with upstream here this way, then resultant will be PR. Then corresponding PR, V u no, then V square minus U square root, here the resultant value, PR value. Now he gonna move perpendicular to the bank, but he have to swim with inclination alpha with upstream, then resultant, because of that resultant, he move A to B, that means perpendicular to the bank. Now here time to move A to B, now here displacement A, then along that direction velocity PR, then A over V square minus U square root. Here it is, A over V square minus U square root. Okay, so if we need to move B to A, then here P, no? Then you have to think about this way, no? Then we can count that one as previous one. Then perpendicular to A, here AB motion, BA motion, both same, no? Then TAB and TBA both are same. But previous case, TAB, TBA different, no? But this case, perpendicular to the bank, we can see same time durations. Okay, do that. Okay, here this analysis is very important. This analysis is very important. No? Okay, now let's see. Now we know how to move downstream and upstream. We know how to move perpendicular to the bank and back. Now let's see with some inclinations. So that inclination can be downstream or upstream inclination. Whatever it is, okay, we can do the thing. Okay, now let's see. I'll sketch it again. Okay, now here the case. You think here A, you think here B. So A to B motion. Take this inclination alpha. Then here PQ, U magnitude U, no? Then QRV, take Q center, radius V circle, sketch. Here it is. Now we need to move A to B, no? Need to move A to B. A to B. Then take that direction. Then corresponding R will be this. Then here resultant, to move along that direction, he has to swim along this way. So with downstream inclination beta, he have to move, no? So he need to swim with velocity v, angle beta, then vu resultant will be here PR. Then take here A, then time to move A to B. So that is A divided by PR. Now you need to find PR value. Now see my method, this method. You sketch perpendicular this. Now here we know U, here angle known, then here this will be U sin alpha, no? Here U sin alpha. Then here V, it is right angle triangle. Then here this will be V square minus U square root, no? Pythagorean theorem, V U sin alpha. V square minus plus, no, V square minus U squared sin square alpha. I write separately. V square minus U squared sin square alpha root, no? Here apply Pythagorean theorem for this V square minus U square sin square alpha. And for this one, here U cos alpha, no? Resolve. Here, the best method. Now anyway, PR now, addition of that. Then you can write PR1, say PR1, U cos alpha plus V square minus U square sin squared alpha. V square minus U squared sin squared alpha root plus U cos alpha. Now here, the velocity now. Then corresponding time A over PR1, PR, it is PR. Then V square minus U squared sin squared alpha root plus U cos alpha. Here the time. That's the time. Okay, complete that. That is A to B motion. Then later we will discuss B to A motion. So B to A motion, we can think about opposite direction. Then we can similarly do. First complete this. Then you can consider any angle, 30 degree, 60 degree, 45 degree, whatever it is, okay. So this method always common. Complete. Okay, then B to A motion, here this way, then here this will be R, say R dash, here point P, then here the triangle U. Then same length we can find here radius V, no? Here U sin alpha, then V square minus U square root, here U cos alpha, then the balance will be the value, no? Then PR dash equal, here V square minus U square sin square alpha minus U cos alpha. Here minus will be the corresponding result. Now TBA time A over PR dash. Then here it is. That is it. Complete. Okay, see that calculation again. Here, this one U sin alpha. Here this radius V. Then consider this right angle triangle. Then V squared minus U square sin square alpha mean this length. Then same length we can take, no? Then here U cos alpha, here this length. Then we need balance. Then V squared minus U square sin square alpha minus U cos alpha. Then by this, you remove this. Then you can find the corresponding velocity, no? That's how we take. Now we know how to move downstream and upstream. Again, we know how to move perpendicular to the bank and come back. Then here this way and the opposite direction. Now let's see again. with some inclination up with upstream, AB, you try to take that A to B and B to A. You try to take that, take your time. Okay, complete. Sketch PQ, U, QR, radius V circle, Q center. Now A to B motion, you have to consider here R, its inclination alpha, then radius here V. Now here best technique, you produce this and sketch perpendicular from here angle alpha, no? Then this will be U sin alpha. Here U sin alpha, then find this length. Here V, no? Apply Pythagorean theorem, V square minus U square sin squared alpha. By that you substitute, remove U cos alpha length, no? Here U, no? This is U cos alpha. Then PR, say R1, then PR1, here this length V squared minus U square sin squared alpha. By that remove U cos alpha. Remove U cos alpha. Then here V, here U sin alpha, then V square minus U square sin alpha minus U cos alpha. Then trying to move from A to B, A divided by PR1, then A over V square minus U squared sin squared alpha root plus minus U cos alpha. Here the time taken now. Then B to A motion, same diagram you can consider. Here say R2. Then here the triangle V. Then find this length, that is V square minus U square sin alpha, add U cos alpha. Then PR2, V square minus U squared sin squared alpha root plus U cos alpha. Then finally TBA, A over PR2, A over V square minus U square sin squared alpha root, only for this part, okay, plus U cos alpha. Then square root only for V square minus U square sin squared alpha, no? Then we know how to move any direction in the river, no? The downstream, upstream, perpendicular to the bank and back. Then any angle downstream with any angle with upstream and come back. That's how we analyze. This is very important thing. Then you know how to sketch circle, you know how to sketch the corresponding, you know how to get corresponding values for each case. This is very important technique. Here very short method when finding resultant velocity, okay. Or otherwise you can consider triangle, you can consider any other geometry, you can consider sine rule, cosine rule, whatever it is, okay. But the best technique is that. Okay. Complete. Okay. Now we know how to move straight line, linear path, no? Linear path. Then there can be some circuits. There can be some circuits like this. Here A to B, B to C, C to A, AB, BC, CD, DA. Likewise, there can be full circuits. AB, BC, CA. Likewise, triangular circuit, square shaped circuits. Let's analyze one by one. Okay. Consider, write down. Consider the following circuits. Consider the following circuits where the man swim. Where the man swim. Okay, here you need to consider velocity of the river V and velocity of the man in still water V. Okay, same data set. Okay, V value greater than U case. See this, I'll do. See this one. Here the river. Now take this circuit first. A, B, C, D. A to B, B to C, C to D, D to A. Then motion A, B, C, D, A. Here the path. Okay. So here this data set always common. Now we have to think about 4 cases, no? A to B motion, B to C motion, C to D motion, D to A motion. We have to consider 4 cases. Now, velocity of man with respect to earth, we have 4 cases. So let's put it here. Velocity of man with respect to earth, we have 4 cases. First one, second one, third one, fourth one. We have 4 cases. So here I am going to do everything at once. See clearly, yeah? Now here first one, then second one, these are the vectors, here third one, and here fourth one. We have 4 cases. Okay? Now when we have 4 cases, now PQ, that is fixed, no? PQ, velocity of the river, that is fixed. Then PQ won't change. You sketch it. Here PQ, U. Then QR. QR, velocity of the man with respect to river. But here we have 4 cases now. Then you put X here, QRX. Then X. 1, 2, 3, 4. We have 4 cases. Then each we can represent one single expression. Now the resultant will be PR, no? Here PR. Then we change R1, say R1 here. Then take P, here PR2. And take here PR3. And take here PR4. Likewise, you can take all. Here PR1, PR2, PR3, PR4. Then all R points on this circle. Then PR1, here it is. We can find that, no? PR1, U plus V. Then PR2, sketch it. Then this will be R2. Then here V, no? Then resultant PR2, apply Pythagorean theorem. V square minus U square root. Then PR3, opposite direction. This will be R3. Then PR3, V minus U, no? Here V, U, V minus U. Then PR4, here it is. PR4, PR2 both same, no? Here U, V, no? Then PR2, PR4 same. Likewise, we can do everything at once. So anyway, you consider here square with side simple A. Now we can find time. Then total time taken, A divided by PR1, A divided by PR2, A divided by PR3, A divided by PR4. Now here the total time taken. Now we can find everything we know. Everything we know. How you can substitute and find the corresponding value. Okay, start it and complete. Later you check simplification. Okay. Complete. Okay, let's start. Now let's consider another circuit. Okay. Now here you consider here this circuit. Here equilateral triangle, side simple A, A, B, C. Here circuit A, B, C, A. Okay. Now velocity of the river, you better do with me. Velocity of the river U, velocity of man with respect to river V. Here A to B motion. So let's analyze all at once. Then BC motion. Then CA motion. Then here V. Here U. Here we have three cases. Then PQ vector, here QR vector, we have three cases, put x equal 1, 2, 3. Then here PR1, here PR2, here PR3. Likewise, you get all three cases at once. Now continue. Now sketch PQ vector first. Here PQ, U, QR, Q center, radius V circle. sketch properly. Q center. Q center circle. Radius V. Here possible R points on this circle. Then PR1 is this. PR1 U plus V. Then PR2 60 inclination. Here R2 complete. Here V. PR2. Then produce. Here you sketch perpendicular. Here this is U sin 60. U sin 60 root 3 U over 2. Then apply Pythagorean theorem to find this. Then V square minus root 3 U over 2 square root. Then PR2 value. Apply Pythagorean theorem. V square minus root 3 U over 2 square root plus here U cos 60. U cos 60. Then here 4V squared 3U square root U cos 60 half. Here the value PR2. Then PR3 here this is P no. Then R3 is here. Then PR2, PR3 both same no according to symmetricity. Here you can say here PR3 equal. PR2, PR3 same. Okay. Now PR2, PR3 same. Then you know everything now. Now you can find time. Then corresponding time U over PR1, U over PR2, U over PR3. Okay, now you can complete now. Then A over U plus V. Yep, these two same no. 2U over 4U square minus 3V square root plus U over 2. Then simplify. Here 2A. U plus V. Here 4A. 4U square minus 3V square plus U root. Now simplify. You can multiply by conjugate here. Then further you can simplify. Then final answer will be here when you multiply by conjugate 4U square minus 3 square minus U no upstairs U. Then here this come 4U square minus 4V square. Then cancel with 4. Take A outside. Minus U cancel. Here V plus 4U square minus 3V square root. Divide by U square minus V square. Okay, this will be final answer. I missed few steps, but you can do multiply by conjugate, simplify and proceed. Okay, complete. Here U cos 60 minus, U cos 60 minus, minus, U cos 60 minus, then here minus, then plus U no, V minus U, answer won't change, answer okay, here minus. 4v squared, 4v squared, 4v squared, 3u squared, 4v, 3u. Okay, check that simplification. Okay, let's check the simplification. Here we had a over u plus v, 2a over 4v square minus 3u square minus u, here root divide by 2. Put this on here. Then a, v plus u, here 4a, 4v square minus 3u square minus u. Then multiply by conjugate, 4v square minus 3u square plus u with root. Like this. Then here 4v square minus 3u square minus u square, that will be 4v square minus u square. Okay, then you can cancel with 4. Then final one, a over v plus u, a 4v square minus 3u square root plus u over v square minus u square, v squared minus u square. Okay, then you multiply here again conjugate v minus u. Now here we have common denominator v square minus u square. Then take a outside, cancel u, then v plus 4v square minus 3u square root. A times v plus 4v square minus 3 square root, v square minus u square. Okay, likewise you can simplify. Okay, now let's try another one. You take this, consider this one, take this triangle A, B, C, equilateral triangle, 60 degree, 60 degree. Okay, you start it. Okay. Now here we have three cases. Here first one A to B to the horizontal 30 inclination, B to C again to the horizontal 30, CA. Now we have three cases here. Now take PQ1, PQ2, PR1, PR2, PR3. Okay, those are the cases. Now, further you continue. Now sketch circle. First PQ, U, QR vector V, Q center, V radius. Then PR1, .30, here U sin 30, U/2, here V. Then PR2, PR3, V. Okay. Likewise, continue now. Here this is P. Okay. Then PR1 apply Pythagorean theorem. Then PR1 apply Pythagorean V square U/2 square root plus U cos 30. Then 4V square minus U square root 3 U/2. Then PR2, then when you produce this, we get PR2 with minus here. Then 4V square minus U square minus √3U divide by 2. Then PR3 apply Pythagorean V square minus U square root. V square minus U square root. Now we can take time now. Continue. Now the total time taken A over PR1, A over PR2, A over PR3. Now A, PR1, 4V square minus U squared, root 3U/2. A, 4V square minus U square root 3U minus over 2 plus A over V square minus U square root. Now put 2 upstairs and multiply. Then 2A common. Then we have conjugate pair 4V square minus U square minus √3U squared. Then upstairs 4V square minus U square root minus √3U plus, in cross multiply, 4V square minus U squared root √3U. a plus v square minus u square root. Then for a, for v square minus u square root, for v square minus u squared, multiply by rationalized denominator there, v square minus u square root. Now it is done. Now denominator rational, we can get simplest form. In final version, v square minus u square, a take outside, 4v square minus u square root plus v square minus u square root. V square minus u square root. You have to practice that simplification. We have irrational expression. In rationalization process, you have to practice with expressions. Okay. Okay. Now see. Now we know how to move any direction. We know how to move any directions, no? Then there can be different circuits. Let's do last one. So it's look like a hexagon. Now last one, you try this one. Here A, B, C, D, E, F, A. Consider this circuit. Here regular hexagon. Okay. As last one, you complete that one. Okay. Then this is about motion in a river. Okay. Then all the cases now we have done. All the cases we have done, but we have to practice more questions. So I gave you the cases, but question by question we need to analyze each case now. Okay. You complete this one. Huh? Just complete. We can complete that lesson. Okay. Complete that question.